Welcome to our channel Immortal Words. In this video we will look for Chandrayan 3 rocket launching on July 14th at Sriharikota. We will also look details about this mission and what are all the problems facing while rover landing on the moon. The Indian Space Research Organization ISRO is all set to send the Chandrayan 3 spacecraft to the moon on the 14th of July, 2:35 p.m. It is India's biggest dream project. We will see the details. Chandrayan 3 is a follow-on mission to Chandrayan 2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It will be launched by LVM-3 from SDSC Shah, Sriharikota. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth shape payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Lander payloads. Chandra's surface thermophysical experiment, CHASE, to measure the thermal conductivity and temperature. Instrument for lunar seismic activity ILSA for measuring the seismicity around the landing site. Langmuir probe, LP, to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies. Rover payloads. Alpha particle X-ray spectrometer APXS and laser-induced breakdown spectroscope LIBS for deriving the elemental composition in the vicinity of landing site. Chandrayan 3 consists of an indigenous lander module LM, propulsion module PM, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition which will be operated post-separation of lander module. The launcher identified for Chandrayan 3 is GSLV Mark 3, which will place the integrated module in an elliptic parking orbit EPO of size tilde 170 by 36,500 km. The mission objectives of Chandrayan 3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies are present in lander such as altimeters, laser or RF-based altimeters, velocimeters, laser Doppler velocimeter or lander horizontal velocity camera, inertial measurement, laser gyro-based inertial referencing and accelerometer package, propulsion system, 800N throttleable liquid engines, 58N attitude thrusters or throttleable engine control electronics, navigation, guidance or control NGC, powered descent trajectory design and associate software elements, hazard detection and avoidance, lander hazard detection or avoidance camera and processing algorithm. Landing leg mechanism. To demonstrate the above said advanced technologies in Earth condition, several lander special tests have been planned and carried out successfully, viz. Integrated core test for the demonstration of integrated sensors or navigation performance test using helicopter as test platform. Integrated hot test for the demonstration of closed loop performance test with sensors, actuators and NGC using tower crane as test platform. Lander leg mechanism performance test on a lunar simulant. Test bed simulating different touchdown conditions. As ISRO has sent Chandrayan 3 to the moon on the 14th, the landing is still a horse-horned affair. What are the problems in launching a spaceship on the moon? Why does it fail? Why didn't scientists figure out the moon landing problem earlier? Let's see detailed information about it. India has successfully sent Chandrayan 1 spacecraft to the moon for exploration. After that, Chandrayaan 2 had trouble landing on the moon and its lander crashed into the moon. Thus, Chandrayaan 2 did not succeed. Not only India, but recently Japan's spaceship also failed to land properly on the moon. So, what is the problem with landing a spacecraft on the moon? Here we are going to see why scientists see it as a horse horn thing. Landing a spacecraft on the moon is not really a simple matter. There are various calculations to be made in this. Everything has to be planned in advance, including the route the spacecraft will take. You have to start the engines of the spaceship at the right time. Before that, it is necessary to calculate the exact time and plan so that the rocket leaves the Earth at the right moment. At the same time, when the spacecraft lands on the moon, it is necessary to reduce its speed at the right time. Even if there is a mistake in any one of these things, there will be a problem in landing the spacecraft. Chandrayaan 3 is currently launched by LMP-3 rocket. The rocket's propulsion will carry the lander and rover up to 100 kilometers from the moon. The lander and rover will come out of propulsion when they are above 100 kilometers from the moon. The second it comes out of propulsion, it begins to sink into the moon. The gravity of the moon is 1/6 that of the Earth, so the lander will fall very slowly, unlike the Earth. Since the rover is inside the lander, the two are unlikely to separate. It must control the speed of the lander as it falls. If it falls down at high speed, it will collide with the moon and get damaged. At the same time, it should not fall straight and go sideways. For this, the lander's engines are designed to travel in all directions. It will precisely calculate its speed and everything else while falling and control itself to provide a soft landing. It can only function completely autonomously. It is programmed for that. Launching this lander from Earth would be impossible. Because the information from here can take up to a few hours to reach the moon, so the lander can't hold on for that long, so they designed it to work automatically. When landing on the moon, the lander must descend at a steady rate of only 3 meters. If it lands like that, it will be a soft landing. By calculating this, they have designed the lander that will land Chandrayaan 3 on the moon. The rover will come out of the lander only after the lander successfully lands. A program is also made for this. Once the rover leaves the lander, the project becomes a successful project. The rover will usually go to the moon and begin its explorations. Then from there it starts doing various things like taking photos, testing the samples. It sends that information back to Earth. Conclusion. When we do something difficult, we inspire others to think it's not rocket science. But what ISRO is doing is really rocket science, so there are many issues and problems. It is through all this that our ISRO scientists are going to achieve this feat, and we should always support them. Thank you for watching this video. Please subscribe my channel to more details.